information about why we're organizing this seminar tonight. So this seminar is part of a broader workshop that we're organizing, that SIGA is organizing this week. We have about 30 PhD students from across the social sciences who are coming from Berkeley, but basically a third of them I think are from Berkeley, but the rest is coming from all over the US and the world, to learn about emerging tools and practices in transparent research and more rigorous research. And so we started at the beginning of the week with more conceptual issues about the big issues today in different research practices, like things like communication bias or the ethics of running field experiments, and progressively we moved to very hands-on activities and how you can actually document and manage your research projects to be fully reproducible and transparent. And so this afternoon and tomorrow morning we had some training session with the D-Lab, and we're thinking that there are a lot of people doing, a lot of data scientists, programmers, and developers doing great work on the campus, and increasingly their work interacts with social scientists. And so there are three people that work in the field of data science, if we can call it this way, and we've been working on collaborative projects with social scientists, and we'll talk about how their work interacts and some of the challenges they are facing and how they solve those problems. So we're thinking, there's a lot of great people working on great things, so we want to connect social science and data science. So led to my colleague Dave Clark here, who's going to moderate the panel. And so we have a bar after, so just ask you wait for the end of the, I think you know by 6:45 to start drinking.
Should I? Does everybody want their own? Sure. And then I'll grab assuming it.
Yeah, you can lay down the beat.
Sorry, what?
Or you can lay down the beat.
That was a tribute to Russ, a very bad tribute to Russ. So to continue with the positivity, I guess I want to frame the discussion a little bit and just kind of get an idea of why you guys agreed to be here. So I think I'll throw out two possibilities. The first would be that this stuff is all just terribly easy. And I think probably some of the people who are here today are here for some reason. I think the other thing that comes to mind is that this stuff is terribly important. And I don't like to lay it on too heavy all the time, but I will right now. It could be a matter of life and death to do science right or do science wrong. So with that spectrum of possibility, I'd just be curious to hear briefly where you fall in terms of your engagement with data science and social science.
I guess I'll start in the middle. My name is Kevin Coy. I am the Executive Director for the Geospatial Innovation Facility here on campus. And I've seen a lot of really interesting things happening between the social sciences and data science and physical sciences over the years. And that's one of the reasons I thought it would be fun to participate in this panel. So we do all sorts of things at the facility in terms of training and advising and project work. And interestingly, the GIF, the Geospatial Facility, is part of the College of Natural Resources and definitely came from a background in forestry and biology, but really have opened doors to kind of any interest in any domains. And what we've seen is a lot of interest from all over campus, and particularly in the social sciences. I see lots of folks coming to learn more and ask questions and do great work. So I think that's been really fun. I guess I can elaborate on some specifics a bit later.
So my name is Anna Nelson, and I'd like to say I'm here because this is important, and it definitely is. is, but I'm a yak shaver at heart, and that means I love playing with neat things. And that has been, you know, just as much of a draw for me as the desire to see science done right. And of course, you know, we're at a point where, you know, our survival as individuals and as a species does depend on doing science right. And, you know, having the great tools to make that possible are obviously a really important part of it. They're what, on a day-to-day basis, I love to do and I love to build. But I think that, you know, the bigger picture is also so important to me, and I love science. I'd like to make it easier for people to do good science, to have the nudges going in that direction, to have the tools available. And I'm just so excited to see what people are going to do with the new methodologies and new workflows and new practices that we can develop together.
My name is Karthik Ram, and I run a project called Our Open Sci. It's part of the Museum of Paleontology. And what I do along with a bunch of researchers is try to enable access to data that's out there so people can reproduce existing results and actually build upon resources that we've already put together. And one of the big challenges that I face is trying to get more social scientists on board with these practices, with these tools, and actually making use of data that's already out there. And the reason why I agreed to coming here is all of the grant proposals that I've written in the past couple of years, the feedback has been, why aren't you talking to more social scientists? Why aren't they more involved? And my response is always, I'm trying. I'm always talking to people. And I find early adopters in small pockets, and the first thing they tell me is, I'm totally sold, but my colleagues are not, and I really have no idea what to do. So it's a big cultural challenge, but I think part of the reason why the present time is really exciting is that we finally have this critical mass, and slowly the culture is shifting in all these different domains, and you're starting to see that across the board. So I'm hoping to nudge people more in that direction and get them to follow these good practices.
So I'll say generally, if somebody has a really pressing question that they want to jump in with, I think we'd like this to be pretty interactive, but maybe we'll prefer to lay some groundwork and then we'll bring some people in as we go. So, thank you for coming. I think the common thread that I hear from all of you guys, girls, women, is the service that your particular tools or facility are providing to other people. And I wonder if that might be a good way to, so I have a script with some basic questions, but the first question is about, as you're developing tools or services for people, there's this desire to give people the power and the flexibility to do anything they might want, right? Which is what I want when I'm getting a tool or a service. But on the flip side, you're from the point of view of scientific integrity and validity, you want to make these tools hard to abuse, okay? Which is what I want when other people are using tools. So I wonder if you could maybe use specific examples of like some of the people you've worked with where there's been some danger of veering off into bad science. And on the flip side, where the users that have been coming to you maybe have innovated in ways that you couldn't predict.
I'll jump in. The reason is because it's kind of fresh in my mind right now. If you Google dynamic ecology and the word blog, the very first blog post, which went up a couple of days ago, deals with this exact same topic. And it's written by a statistician complaining that we have all these tools that we're putting at the disposal of people that don't really understand what they're doing. And so, are we in danger of enabling more bad science with easy-to-use tools? And if you read the comments, it's all about giving monkeys razor blades, and now they're going nuts. So I don't fully agree with a lot of the sentiments in the blog post, but I certainly understand the dangers that come with sort of software. For example, most of the software that's been around for the last couple of decades for social scientists like SPSS and JUMP and whatever else The idea being that we'll reduce the barrier to using these tools. They can be one click, you just choose a model off a menu and then it spits out a result and everything's great. But you don't really understand the assumptions that went into the model, and now you have something that looks like it could be interesting, but you don't really know. The other extreme is making it so difficult. And so the whole point of that blog post was that we want to keep the barrier really high, so people must fully understand and be fully invested before they can use these things. And I disagree with that as well. So I think the real challenge is meeting people halfway, is not dumbing things down so much that people can just use them and abuse them, but at the same time give them a set of skills to understand what they're doing and also understand the limitations of these tools. So there's at least a little bit of investment. So the way I think about it is I'm a biologist, and I've never ever started an experiment the very first day and then used those results. I've usually spent a month or two in a new system, failing, learning how to use a microscope, understanding how a particular organism behaves. So I might be observing useless data the first time around, and I get all of that out of the way. But for some reason, when it comes to programming or using these different kinds of tools that we have, like version control, we just assume that people should not be wasting time on this. Let's just grab something out of the box, use it, it'll be fine. And so the same level of detail that we give to calibrating a microscope or calibrating a scale before we take the first measurement, we don't do that with tools that involve fitting models and getting actual results, which is the basis for our paper. And so, so that's what I think is the challenge, is we can't dumb things down too much, and we can't keep things too complicated. We just need researchers to meet tool developers about halfway.
And I think it's an interesting framing that there's that tension between easy to use and easy to abuse. And I think that's not necessarily always the case. I think the barriers to entry can prevent making something more difficult to prevent people from misusing it, but also just make it more difficult for people to use it correctly. And I think the approach that I would like to see, or the approach that I think is going to help us with that, is to make it as easy as possible to evaluate what approach someone else took, so we can go in and say, actually that wasn't a great statistical model. We can go in and say, oh, okay, they did it this way, and that's why they got this result. And so for me, that's where the computational reproducibility really comes into it, is it doesn't matter if someone's using an easy tool or a more complicated tool. That shouldn't be our barrier to entry. But what we should have is a way to establish, here's in a transparent and easy to observe way, how they did the work, whether that was an appropriate tool selection, and whether they used it correctly. And then that becomes a part of an ongoing peer review process. So I'd rather we not have it be a case of, well, here's a barrier to entry. You have to work really hard to get over this barrier to entry. So we're going to assume that means you did it correctly. I don't think that's necessarily reliable. And I think where I would like to see us able to spend our time is I'd like it to take about 5 minutes for you to figure out how someone got the results in their paper. Then we can have our conversation be about that. Whereas right now, you look at someone's paper, you have no idea how they actually got those results. Even if they publish sources, there's a very high time cost to you to actually get the specifics of that and figure out the specifics of how they did what they did. Make sure they didn't, figure out if they actually applied an appropriate model, figure out if they did that correctly, figure out if they made any typos. I'd like to see us have more time in the evaluation and in the discussion of how that works. And I think our tools can enable us to have that transparency to make that lower cost.
I was just going to suggest transitioning, so laying out the problem space, the impression I got from you was maybe you have some good success stories where you really have good collaborations and found ways to find that meeting in the middle.
Sure, yeah, actually, so kind of two specific things that come to mind during this conversation. In the mapping world, Google Earth came out a few years ago, dozens of years ago, I don't even remember. But from a GIS perspective, the specialists who've been working so hard in mapping software looked at this and said, this is not right. Non-specialists are going to get their hands on this and not be able to appropriately use good geographic data clearly that was not the case, and I think anytime you see new technology lowering the barrier of entry to a particular science, there's always going to be this tension, but there always tends to be, I think, much more benefit than actual harm done. And we saw the same thing. We have a climate change website for the state of California called CalAdapt. And this takes a really huge amount of complicated climate data that the scientists have developed and typically existed in arcane formats that only a handful of people could ever really read and do anything with. And we made it very simple now for anyone to click on a map and get very detailed information for any local area. And before we did that, we vetted the tools, each individual tool, with the particular scientists who made the data. And we definitely got a lot of tension and nervousness that having the ease of information out there is going to make it very easy to use this information or use it incorrectly. But to be honest, I haven't seen that happen. The site's been up for 2 years now. Everything's been rather positive, but I would echo the fact that the beauty of reproducibility is people have been able to lie or abuse statistics and maps for a long time, but now with reproducible code, it's easier than ever to actually verify if those things are legitimate.
I'll jump in with one comment to follow up on this, is that I'd like to echo what you said. It's pretty great to actually look at a paper and be able to run the results and actually tell them what's wrong. And A, it's great because that's really part of the peer review process. You can tell people how to fix things, or it's pretty easy to reject bad science. But I've been through so many situations where I can review a paper, I know they did not fit the models they're describing. It's actually very clear to me. And I requested their data, I requested their code, but you get nothing back. And the only thing I can do is privately communicate to the editor saying, they have really made something up here that I don't understand. And sure enough, the paper gets rejected, but I would see the same paper verbatim and nothing changed show up in a different journal. It's like, you're just trying to get through it. There's really no barrier to stopping you. But these barriers can also make it hard for people with good intentions to get their stuff out there. So one of the challenges that I see is basically people that are putting time and effort into doing this don't get any reward for what they do. And the same challenges are around data as well. So people who share data tend to see more value, tend to see more collaborations, tend to support science a lot more, but we don't actually favor any of those things at this point. And so a lot of different parts have to move at the same time for more people to start doing these things. Okay.
I was just going to say if anybody had any other success stories, or any.
Oh, I actually have a success story. So, but again, this was a little bit contrived. It's a bit of a contrived example, but a year and a half ago, I was editing a special issue of the journal, and a group of authors who submitted an article decided to write the article in the open on GitHub. And so it was really interesting just to see the article come together, and I could actually see the contributions coming in from everyone. And the best part was that the reviewers that I assigned to the article were also on GitHub, and they decided instead of submitting reviews the traditional way as a PDF, where you respond line by line, it ended up going on GitHub issues, and it just ended up going from a one-sided conversation to, can you fix this, or I don't understand this, leading to the authors having to write a 4-page explanation, trying not to call them a complete idiot, to an actual conversation. And at the end of all of this, the paper was infinitely better. And one of the reviewers and the lead author of this paper ended up in a new collaboration because the questions from the reviewer were actually very, very useful. And so now it's turned into a new piece of software and a new publication between those two. And so these kinds of tools that we have can actually enable better science, but it's really hard to see that until you actually practice these new approaches.
Sorry, just a quick thing on that. From my small knowledge of this, in social science, often the editors are not known to be the editors or how would this?
Yeah, so that would have to change. At least, sorry? Oh, It's not common in the social sciences for editors or reviewer identities to be revealed. That's actually changing quite a bit these days, at least in ecology and evolution and a bunch of other fields where most of us are quite happy to sign our reviews. I don't want to hide behind that anonymity, and if you have an issue with my review, please get in touch. And so this particular journal actually requires reviewers to not be anonymous. And if you have a problem with that, you don't even take on the review. So there was no choice for the identities not to be known.
So unless you have other positive examples you'd like to share, I'll point out the examples that have been coming from positive collaborations here. They seem focused on sort of geospatial, climate, biology, and here we are, the something, social sciences. And so, where's the pathway for the social science? I mean, and then you said yourself that you're having trouble making traction, but where do you guys see opportunities for actually engaging social scientists? Where might we be in the next few years? And where would you like to see us go?
I think this is true for really any domain, but especially I'm sure in social sciences that you truly get excited about something when you're working on something that you're interested in. And so coming from a facility that offers trainings and workshops and things, I find that we get a lot more success when you're able to cater to a specific topic that's of interest so that you're not taking, I don't know, how sewers work and trying to use that model to teach somebody about a suite of tools, rather use a topic that's of interest. But really, when people come with their own data and projects, that tends to be the biggest success. And one of the things I've gotten, it might come up later, but one of the reasons I feel like environmental sciences kind of have an easier time getting data is that we can sense a lot of it. So we have satellite images and sensors everywhere, and it's pretty easy to get a whole lot of data. And I find often that when people come in with more social questions, you're dealing with personal data often, and that's a big roadblock in terms of having easy accessibility to it, or you literally have to go out and gather it yourself, and it might be more challenging. On the flip side, there's tons of public data becoming available from federal to local levels that are making these things easier and easier as we go. So I feel like there's a lot of opportunity, and again, I feel like there's also opportunity for these domains to mix. And so, for instance, the climate science things I was talking about, we work particularly with the ecologists or folks who are using the data in a particular way, but then others have mixed it with census data to see who's vulnerable to certain potential risks and that sort of thing. That the same data are useful in many different ways.
I started out as an economist, and we're certainly looking back at the field of economics now has had two very visible Excel spreadsheet scandals in the last year, which have been very embarrassing. I mean, it seemed at the moment as one was material and the other may not have been as material. But there's definitely, I know, when I started getting into having more contact with the scientific tooling community, there are certain fields where computers have been in use and where those skills have been necessary for a really long time. So you look at astronomy and bioinformatics, where they've had to learn how to program for many years because there was no other way to handle that data. And I think there's certainly in some other fields that awareness hasn't gotten there yet because the need is not as apparent. Although I think even if it's not a question of volume of data, I think now the fact that we are seeing a lot more looking back at old papers, doing meta-analyses, looking for errors and looking for other problems, we're going to realize, well, even if you don't have a huge amount of data, how you work with that is very important. And looking at the more transparent workflows, it's sad that it's going to take a serious crisis and a serious crisis of confidence, or several, to make people realize that Excel is really not a viable research tool, and it's a lot less transparent than one of the other options. And I think there is a huge, there is a lot of investment required from individuals and from departments and from organizations to have a different skill level. But I think it's becoming more and more apparent that's what we need to do, and that's that there. These more transparent ways of working and these more auditable ways of working are going to become more important. And it's how we make that transition and at what point the pressure comes from is something that we're all obviously looking towards and hoping towards.
One of the challenges that's been pretty apparent is, at least in the social sciences, there hasn't been a culture of being heavily quantitative. At least that's been my impression the whole time. And so if you're one or a few people within a department trying to work together, it's really a very uphill battle to get more quantitative and get more transparent. And I'll give you an example, at least within the domain that I work in. Even 10 years ago, there was a lot of pushback against working with these kinds of tools. My PhD advisor at the time told me not to use R, and he promised to buy me a license for SAS for the rest of my life if I promised not to use R. But now he calls me up all the time and finds very exciting things to do in R. So it takes a while for people to come around, and so there's that. The second is, as Anna said, astrophysics and bioinformatics have been ahead of the curve for a very, very long time. They've also had a bigger culture of openness. They've had archive for a very long time. Preprints are now just becoming common in biology and other fields. And so it's going to take quite a bit of training, like the programs that D-Lab is doing, and enough of a critical mass of people doing these kinds of things before it fully catches on. So part of it is also a little bit of a generational change needs to happen. And once that does, and departments start to change character, you'll start to see more of these tools. But to me, it's sad that we have to have these kinds of crises and the whole robot type scandals for people to think about these things some more. But I actually don't like that approach. I'd rather see people getting huge wins by doing these things and then saying this is amazing. And people reading about it and going, this is really useful and it's actually worth my time to do this, instead of I'm doing this because now somebody's got a stick, they want me to do this, otherwise they don't get my funding.
So I want to push a little back against the unilateral astrophysics and genomics is ahead of the curve. What have the social scientists got, right? I mean, coming from the social sciences side, I absolutely have no trouble coming up with examples where, this like person who knows how to process a lot of data has started doing this analysis of education. Now they are like talking about they understand things in a very deep way. Right? And the social scientists, the people who have been studying education for a while, are just like, oh no. So how do we get the flow going both ways, recognizing where social scientists may affect the if you're willing to grant that social science may affect.
Absolutely. I think there's a lot to be learned on both sides. I don't think there's an either or. And in my point of view, qualitative data provides a tremendous amount of information and utility that often is kind of looked down on or not used at all in a more quantitative field. And I could give an example actually. I was thinking about where that kind of information came in really handy and provided a whole lot of knowledge that we wouldn't have had otherwise. So